Everyone, thanks for joining me today. My name is Joe DeNave and I'm a senior sales engineer at Lightbits, and I'm here to talk to you about simplifying persistent storage in OpenShift at scale. If you haven't worked with Lightbits before, here are some things you need to know. Our mission is to make high-performance block storage that's scalable, resilient, and efficient. We were founded in 2016 by experts in storage and networking, and we're the ones who invented the NVMe over TCP protocol. For those not familiar, that's the technology that allows high-performance, low-latency storage using NVMe over Ethernet networks. The Lightbits data platform is deployed in public, private, and hybrid clouds, and we're talking customers in financial services, e-commerce, AI cloud, cloud providers, managed service providers, and other large enterprises. We have the support of a broad range of investors like Intel, Cisco, Dell, JPMC, Lenovo, and more. We're experiencing exceptional year-over-year growth and have been recognized for our leadership in storage technology with a number of industry awards. Now, a 16-node Lightbits cluster is capable of delivering up to 75 million IOPS to meet the needs of storage-intensive workloads. It achieves latency as low as 160 microseconds, with a tail latency that remains under a millisecond in worst-case scenarios. Lightbits also has a patented intelligent flash management technology that can dramatically extend the life of NVMe flash drives by up to 20 times. Now, any of you out there who've worked with Kubernetes or OpenShift know that persistent storage in these environments is pretty complex. This gets even more true as clusters grow in size. Now, managing this storage manually at scale leads to inefficiencies, bottlenecks, and operational headaches, to say the absolute least. But what if there was a way to streamline it all? So by leveraging NVMe over TCP and OpenShift's native integration, we can eliminate traditional storage limitations and optimize performance. Today, I'll walk you through these challenges and show how Lightbits provides an innovative and scalable solution. Let's jump in. So, as you know, OpenShift is a powerful orchestrator for running containerized applications. But when it comes to stateful workloads, and eventually, if you're running OpenShift VMs, storage quickly becomes a challenge. Many applications can statelessly run, right? We're thinking web servers, microservices, APIs. Services like databases, analytics, and AI and machine learning, these require persistent storage. OpenShift provides persistent volumes and persistent volume claims to address this need. However, traditional storage backends are going to introduce some challenges for you. First and foremost, high latency. Many traditional storage solutions aren't designed for containerized environments. This leads to bottlenecks. We also have scalability issues. As the clusters grow, managing the persistent volumes manually becomes inefficient. And honestly, at large scale, it's almost impossible. And we also have complexity issues. Traditional storage management requires a significant operational effort, and this slows down development velocity. Why? Because you have to request the volume to be created from a person, and it has to go through whatever the mechanism is to get that deployed and approvals and all that stuff before it's given to the folks that need it to do their job. So how can we ensure that OpenShift storage remains fast, scalable, and easy to manage? So let me break it down a little further. I want to make sure that everyone's crystal clear on what we're talking about, because I don't know who all is in the audience right now. So we'll start with this. A persistent volume is a storage resource in the OpenShift cluster. This could be an actual disk, a storage array, or a cloud volume. PVs exist independently of any specific pod. A persistent volume claim is how applications request storage. Think of it as the application saying, I need 100 gigabytes of storage. Now, while these concepts help separate storage from compute, they also introduce challenges. As I've said a couple times now, static provisioning is going to be a challenge. This requires administrators to pre-create the persistent volumes before the applications can use them. This leads to inefficiencies as storage may be over-provisioned or underutilized. If a workload storage need changes, resizing or reallocating the persistent volumes is cumbersome and is often going to require someone to step in. Now, I've done this at my home lab. It really didn't take long for me to realize it's really not a good way to handle things. And again, this is just in my lab. I can only imagine what it's like at a large-scale enterprise. Now, there's scaling challenges. As I was saying, in large environments, managing hundreds or thousands of statically provisioned persistent volumes is really impractical. Administrators must predict the demand in advance, and they're not psychic, so this is nearly impossible. And this leads to over and under provisioning with excessive operational overhead and bloated storage costs. This comes from a waste of resources. Since the persistent volumes have to be created beforehand, unused persistent volumes or over-provisioned persistent volumes waste valuable storage capacity. And if you have something that's suddenly growing, it can cause delays in provisioning the additional storage for the reasons I covered earlier. To overcome this, OpenShift supports dynamic provisioning via CSI. Dynamic provisioning allows persistent volumes to be created automatically when a PVC is requested. This eliminates the need for manual intervention. This significantly improves efficiency, scalability, and resource utilization. However, for it to work effectively, the storage backend must support it efficiently. Lightbits NVMe over TCP storage excels in this area. We can ensure fast, on-demand volume creation, optimized resource utilization through thin provisioning, and seamless scalability as the storage needs grow. Let's look at how we can make this process even easier. So Lightbits provides an advanced software-defined storage solution tailored for modern OpenShift environments. But what exactly sets it apart? First of all, performance. We're using NVMe over TCP. Traditional storage solutions suffer from high latency and performance bottlenecks, especially in large distributed OpenShift clusters. Lightbits uses the NVMe over TCP protocol, which delivers ultra-low latency and high throughputs over standard Ethernet networks, ensuring seamless data access and efficient workload execution. We also have true scalability with disaggregated storage. Unlike some storage architectures that tie storage and compute resources together, Lightbits separates storage and compute. This means that as OpenShift clusters scale, storage can scale independently. This allows for a more efficient use of the resources and eliminates the performance constraints of local storage. Native OpenShift integration and dynamic provisioning is something the Lightbits CSI driver allows OpenShift to perform. It can dynamically provision storage without requiring manual intervention. When an application requests storage via a persistent volume claim, Lightbits will automatically allocate and manage the necessary resources. This eliminates the complexity of pre-provisioning persistent volumes and ensures that the storage scales effortlessly as the workload changes. We also have cost efficiency within provisioning. Traditional storage often allocate the full capacity up front, leading to inefficiencies. Lightbits leverages thin provisioning. This ensures that storage is allocated only when it's needed. This prevents over-provisioning, reduces waste, and optimizes cost effectiveness. We also have enterprise-grade reliability and high availability. Stateful applications require resilient storage that remains available even during hardware failures. Lightbits provides built-in data redundancy as well as node-level fault tolerance, ensuring uninterrupted operation and safeguarding against any form of data loss. By implementing Lightbits, OpenShift users benefit from a high-performance, scalable, and cost-effective storage solution. On top of that, it simplifies persistent storage management. Now, let's look real quick on what a deployment's going to look like. So, step one, install the Lightbits CSI driver. This allows OpenShift to interact with Lightbits storage. Second of all, you want to define your storage class. This tells OpenShift how to dynamically provision using Lightbits as the storage type. You also want to make this the default storage type if it's going to be your main backend. Next, you want to create a PVC. This is how applications request storage from Lightbits. Real quick, we're going to just kind of run through it on the next slide. But effectively, you're going to define the storage class, and then OpenShift will dynamically provision the backend. So more or less, this is my real world example. We have a pod named app-pod. The name is my app. The image is nginx. The volume mounts are /data. My storage is the name. The volume, my storage, the persistent volume claim that we create is called my Lightbits-PVC, and it uses the Lightbits storage class. Now, Lightbits provides multiple advantages for OpenShift storage, making an essential solution for large-scale clusters. First, NVMe over TCP ensures ultra low latency and high throughput, providing the speed required for demanding workloads. Traditional storage can struggle to keep up, but with NVMe over TCP, performance remains consistent and reliable. Second, as I said a few times now, dynamic provisioning removes the need for manual intervention. OpenShift automatically provisions the storage when applications need it, and this ensures a seamless and scalable experience without any operational headaches. Third, thin provisioning optimizes storage efficiency by allocating the resources only when they're needed. This means you're not over-provisioning and wasting capacity, and this is going to reduce your costs overall. Scalability is a core advantage of Lightbits. Since storage is decoupled from compute, you can easily scale your storage independently of the compute of your OpenShift nodes, allowing for flexible growth. Finally, resilience and high availability are built into Lightbits. Even during failure, data remains protected, ensuring continuous availability for mission-critical applications. With Lightbits, stateful applications run faster, scale effortlessly, and require minimal manual intervention. To wrap up, persistent volumes and persistent volume claims are the backbone of OpenShift storage, but managing them at scale presents challenges such as complexity, inefficiency, and performance bottlenecks. Lightbits storage eliminates these challenges with NVMe over TCP that provides high performance, scalable, and cost-effective storage that is tailored for OpenShift. The CSI driver automates the storage provisioning, making deployment seamless and reducing operational overhead. With dynamic and thin provisioning, organizations can maximize resource utilization while ensuring enterprise-grade reliability and high availability. Thanks for your time. Please feel free to contact us to ask any questions or to see a demo of how Lightbits can optimize your OpenShift environment. Have a great rest of your day.